Alright, time for another draftphysics.com video presentation. So this will be, I'll start labeling subjects. This is the 5-ton train, 10-ton train thing. I guess I'll label it something like that. 2 mass against 1 mass, blah, blah, blah. The experiment where you lose half the kinetic energy. So you have a 5-ton train going twice the velocity, 5 mass going 2 velocity, and you combine it with another 5 mass. And now you have a 10 mass going 1 velocity as the outcome. And that experiment has been done over and over and over, and that's what you get. You conserve the momentum, but you lose 1/2 the kinetic energy. And a physicist will say words like deformation or heat or something, sparks, sound. And somehow 50% of the kinetic energy is lost to these things. And the simple argument is you can't make any of those things. You can't make heat, you can't make sound, you can't make pieces fly off, you can't make sparks without using momentum. So there's no way you could have 100% of your momentum, nearly 99.9% of your momentum conserved, and then claim you did a whole bunch of other stuff. Okay, that you heated things and you moved things and you did all kinds of other actions. It's irrational mush. Now that's the simple argument. They won't deal with that simple argument. Instead, they just keep arguing other subjects. Okay, so the Leska guy has, again, commented, even though I've kind of told him I don't find him interesting and I don't find his arguments very coherent or useful because he doesn't deal with anything I say. So I've already said what needs to be said on this subject, and he just keeps trying to change the subject. So he changed the scenario by putting a spring in between the two objects. So now when I collect the 0 velocity object, I'm going to compress the spring first. And the spring's compressed based on pressure. So obviously the pressure is going to be felt here. Okay, when the spring hits this, this is going to be opposing the motion. This is also creating opposition to the motion. The only thing that has any motion is this, so this has to sacrifice some of its energy to compress the spring. So he's sort of conceding that in his comment. And so now the claim is, okay, is that the object now has 70 of, so let's say the total momentum we started with was 100. Now the object has 70 in its motion, and it has 30 stored in the spring. So he's conceding that you can't compress the spring without using the momentum. All right, so now we've got 70 in motion, and we've got 30 in a stored energy in the spring. Now he's claiming, okay, that somehow makes momentum break down, and it certainly doesn't create any opportunity to recover this lost kinetic energy. It's impossible to recover it if every single time you take energy from a light thing going fast and go to a big thing going slow, you have to lose a gigantic portion of the momentum, kinetic energy. And that's proven by the gun. The gun, as demonstrated, as Professor Lewin stated, the bullet, okay, loses 100%, almost 99.94% of its kinetic energy to the ballistic pendulum that's measuring its energy. So even though the momentum is okay, conserved, you lose 99% of the kinetic energy. So like this. So every single time, this is just a fact of their formula. You can't, the two formulas are completely incompatible when you're exchanging energy from a light thing to a heavy thing or from a heavy thing to a light thing. You have to either create free momentum and destroy kinetic energy. Well, you either conserve momentum and destroy kinetic energy, or you have to destroy momentum and conserve kinetic energy. You can't do both, can't conserve both. Indicating these are two theories in conflict with each other, not theories that are all compatible. They're completely incompatible theories. Alright, so anyway, back to this scenario. So we're at 70, and then we got 30 in the spring. So the 30 in the spring, his argument is that, when you have two objects on either side of a spring, that they get an equal amount of energy. So if I have a car here and a car here, and they both weigh the same, and put a spring between them, both cars will get an equal amount of energy. Yes, that's true if both cars are stationary, because then both cars are applying the same pressure to the spring. But in this case, this whole thing is moving. Okay, so, and the spring's between, I guess I shouldn't have drawn it this way. I should have drawn it with this over here. But anyway, so this whole thing is moving. Both of these objects are moving with 70 of the momentum total. So they're both moving at a velocity. All right. And in that case, it's a different circumstance. It's not equal. Because if you just think about how the motion's moving, one side of the spring is opposing the motion of an object, right? The object's here. Got to go down. Oof, okay. So the object's on this side of the spring is opposing the expansion of the spring, and this other side is providing no opposition to, it's going the same way. So there's zero pressure here and some amount of pressure over here, some plus pressure. And so it's just like a fluid, it's going to, or a river, it's going to go wherever the easiest path is. So the spring is going to start expanding where there's no pressure. It's not going to expand where there is pressure. And it's just basically going to give all of its momentum, all the energy it's stored, it's going to give to the forward object. Because to give it to the opposite direction is always a higher pressure. So it's always a lower pressure here than it will be here. And so the spring's definitely going to expand in the direction of the lower pressure. And so what you'll end up with is, so you have 35 momentums in this motion, you have 35 in this motion, you have 30 stored here. So it's just a redraw of that. And he's arguing that because springs give equal amounts to both sides when they're stationary, that they give equal to both sides when they're moving. And they don't. And there's no experimental evidence of that, so it's just a nonsense. So this doesn't happen, which means this doesn't happen. You don't send 15 against this and knock this down to 20, and then, because you haven't conserved your momentum then, clearly. So 70 is not conserving the momentum. And what really happens, so this doesn't happen. And what really does happen is the pressure is always less in this direction, and it'll always be less until this pressure equals this pressure, and that just won't happen. Okay, so because this will always be going the same direction, and this will always be going the opposing direction, so the pressure will always be less in this direction. And what will happen is that all of the spring's energy will go into the first object, and the other object will just pretty much stay the same. And then you'll conserve the momentum. So this will be the outcome. Now there's an experiment that actually does parallel this, where I suppose it might be worth erasing something. We'll erase this bit here. Alright. It sort of demonstrates it in that you can have a car and somebody could throw a rubber ball into the car. And the fact is the ball will fly off with more velocity than it was moving at. So say if it had a velocity of 2 here, you'll end up with a velocity of 4 leaving. And what's really happening is it's taking a portion of the car's velocity, okay, is going to end up being in the ball. So it's not going to just bounce. It's going to bounce because this whole spring, the ball is a spring. Okay, so the ball is going to compress when it hits the surface. And when it compresses, okay, it's just like a spring. There's a little spring there. And now the ball has to say, what am I going to do with this energy? Well, obviously the car's got a high amount of momentum moving against it. So there's a high pressure on this side, okay? And there, again, is no pressure on this side. And so obviously the spring will expand in this direction, giving the ball all of the energy. So all of the expansion energy of the ball will end up going into the ball. All of the spring, all of the elasticity, all the elasticity that has been pushed against is now going to see less pressure forward and more pressure towards the car. And so it's going to go, the stream's going to flow downhill. It's going to flow where there's less pressure. And the ball is obviously a lot less pressure than pushing the car. All right. So in this sense, there is physical evidence for what I'm saying. And so now I'll read his obnoxious comment. It sent it by email, so I won't bother showing it on the screen, but whatever. So again, I made all these arguments before, that there's no way you can do anything to this experiment where you will in any way be able to extract the half of the kinetic energy, show where half the kinetic energy was lost, because you can't do it. You can't show heat or something else leaving without explaining how it didn't use any momentum. It has to use momentum. If you make heat, you use momentum. If you compress a spring, you use momentum. If you make anything move in the universe, you have to explain the thing that had momentum that made it move. Nothing moves without something with momentum making the exchange, giving it the energy. Something has to give something energy for something to have energy. All right. You said you don't have any evidence to support my argument. You don't, yes. There are plenty of experiments showing that springs launching two objects always give the same amount of momentum to both sides. So go ahead and show me the experiment where the two objects are moving. So show me the experiment where, yeah, they take two carts with a spring between them, they give them some momentum in a direction, and then pull the spring on the spring and let the spring expand while the two objects are moving in a direction. So show me that experiment. Okay. This is even more obvious when the objects have the same mass, but it's not obvious when the objects are both in motion. And this is a problem for your counter argument. So there is no problem with my counter argument except that you're a nuisance. Okay, regarding the 5-ton trains, your claim is that if the spring is compressed when merging the 5-ton 2-velocity train with the 5-ton 0-velocity train, the 10-ton train will have a velocity less than 1. Obviously, I'm saying if you're storing the energy, you can't use the energy. You can't use the energy twice. If you put the energy into storage, you can't use it to push something until you take it out of storage. You can't take a certain watts of electricity and make a car run with it and also store its battery at the same time. You can't do those two things. That's what I'm saying. All right. Because it lost some momentum. Let's say the velocity is 0.7 for the sake of argument. That's what I did. Okay, you also claim that when the spring is released, one of the 5-ton trains will stop. No, I didn't say that. So I don't think that's my claim at all. Change in momentum equals 5x times 0.7, 3.5. I don't know what use that is. And the other one will have the initial velocity of 2. The initial velocity would be 100% of the momentum. So it's better just to go with the momentum numbers. This means the spring gave different amounts of momentum to the two objects. Yes, it will give all of the energy to the forward object, because to give any of the energy to the backward object would mean it would have to flow in the opposite direction of less pressure. It would mean that the water would have to flow up a hill, and it's not going to do that. It's going to flow, if there's a place to flow downhill, that's where it's going to go. It's always going to go wherever the less pressure is. So anytime I'm building up a pressure, the energy is going to go wherever there's less pressure, and it's going to leak out. And the voltage, so to speak, is going to drop as it's leaking out. And so there's always going to be less and less pressure on the other side. So it starts with a certain pressure. It's too much pressure for the water to go that way. The water goes the easy way. As the water starts going the easy way, the pressure gets less and less on the other side. So it's certainly not going to go the other way when the pressure is reducing. So as the pressure is reducing, it's even less likely to go uphill. All right. This means the spring gave different amounts of momentum to the objects. Yes, because they are in motion. So again, You're just assuming that because when stationary objects, it's the same pressure on both sides of the spring. But when the objects are in motion, there's a different amount of pressure on the two sides of the spring. One side is pushing against the spring. The other side is saying it's an open gate. Go ahead, push all you want in this direction. Move all you want in this direction because I'm not going to resist you. The other side is resisting. This contradicts experimental evidence. Liar. It does not. So fuck you. You don't have any experimental evidence of this done on moving equal masses with a spring between them. So again, you're overstating your argument. Okay, that's what you're doing. You're making shit up. All right. It also contradicts Newton's third law, big fat lie. And everything you're saying contradicts Newton's second law, you liars. Okay, so Newton's second law explicitly says twice the force, twice the velocity. 3 times the force, 3 times the velocity. You're saying you can violate Newton's second law. That's what you're doing, liar. Okay, I'm not the one in contradiction to Newton's laws. You are, liar. Okay, your model doesn't work. Yeah, yours is shit on yours is a shit sandwich. Okay, it's shit in between shit. All right, covered in shit. All right, you fucking piece of shit, lying scum, sucking piece of crap. You are the one saying Newton is wrong. Admit it. I mean, you can't even do that. You're such uncourageous little scum-sucking pieces of shit. All right, it's in bold type right there in Newton's own papers. Okay, so why are you pretending Newton agreed with you when he completely disagreed with what you're stating? It violates entirely his second law, what you're stating. Entirely. It's an entire violation. And you're pretending you're defending it? No, you're shitting on Newton, right on his, dead skull. You're insulting the integrity of his hard work and his diligence and his honesty with your lies that he has anything to do with your wacky, silly, squared velocity bullshit. You lying piece of shit. Okay, so look, the premises are you can't destroy momentum. You can't make free momentum and you can't destroy momentum, and they really don't have any logic or reasoning to defend any of these simple experiments that demonstrate it. Okay, and the five mass going twice the velocity, where you turn it into a 10 mass going half that velocity, that experiment sums it all up. It has every ingredient you need to see the truth. That momentum is the real deal, because that's what's conserved. And kinetic energy is absolute nonsense, because there's just no evidence of its function. And you just keep lying about that simple truth. Okay. So, enough of that video.